Hey folks, in this video I want to do a little overview of the architecture I picked for this project, for this app. Uh, so I'm using Cloudflare um, full stack, meaning for everything. I'm using Cloudflare for the compute, so for the app that is running. I'm using Cloudflare for data storage, using their databases and key value storage, and of course for distribution, for making the app available network. Uh, I asked Codex to generate this a chart of the architecture, but it's too complex. So I'm gonna start with a simple mind map and discuss each piece. Well, the most important pieces. So the architecture first item is the workers. Cloudflare workers are going to be central and a fantastic part of the whole system. So basically, I deploy the app as a worker, and there is a big difference between deploying the app as a worker compared to, for example, deploying it on a VPS or like a standard um, platform as a service tool, because the Cloudflare basically runs the app near the user. So it runs it in countless locations and spins up multiple instances of the app as needed. And this happens automatically without me having to do anything. The app is working as near the user, near their locations, which make it super fast. And also, um, like there is no problem if thousands, millions of people try to access the workers. They work fast. And this is one of the central pieces of the architecture, because I can't possibly imagine hosting this on a single VPS, for example, in a single specific location. I will have to manage um, replication and running on multiple regions, and this is not something like something that gives me headaches. I can't even think about this. So this is fantastic already. The second piece of the architecture I'm gonna use is the database. So Cloudflare offers this database solution based on SQLite called D1. And D1 is like they advertise D1 as a lightweight solution, and the way they built this is not like the traditional database, for example, you could find on any Postgres solution or MySQL, for example, um, Amazon RDS or PlanetScale. Um, on those services, you have basically a big database, typically, and you host all the users' data on that database. While D1, as advertised by Cloudflare, is basically, let me find the documentation. You can see here that Cloudflare has a limit of 50,000 databases per your account. And each database has a maximum size of 10 gigabytes. This means that databases, D1 databases, are not meant as a replacement for those traditional big databases that you need to scale and shard and take care of data growing over time. but they are meant to be tiny, and especially I was reading somewhere that they were built for um, they are perfect, for example, for companies that those tools where you create an account there and then you develop applications, um, especially the AI tools, mm, vibe coding tools. I think they are meant for this, and we're gonna take advantage of this architecture by having one database per each user. So this is not something that is often discussed. I don't think I've ever heard about this. Maybe I don't know how this concept came to my mind, but this has so many advantages that it doesn't make sense to do anything else in my case. First, every user is a paid user. So I will not have like 10,000 users or 50,000 users. That's not even remotely possible, and it's not something I, I even want to do. What I want to do is manage 100, 500, 1,000 people, customers maximum, probably. If I reach 1,000 customers, I'm the happiest person. Uh, let's discuss this database here because it's fantastic. So first, there are a few advantages because if you have like one database per each user, anytime a user creates their account, they have a fresh database with zero data in it, super fast. And when you retrieve data or even insert data, you are not basically you don't have to do where workspace is workspace ID because that's already the database is the workspace. So this is already something huge, especially if you have all the users in a single database, the database is going to be massive. And I don't even know if I would be able to manage all the data on a single database. It would be impossible. And the second thing that is great about um, the individual database solution is that we can have, for example, beta testers that you join like a beta channel. Suppose, for example, someone asks me for a feature, I can develop that feature in isolation with a specific user and change their database schema according to the new needs of this feature. That's pretty cool, actually. And you have more security, of course, and uh, data is sits on its own database, which will make things easier for many aspects, including GDPR, for example. And I still have to wrap my head about around some of those topics, but um, if a user is deleted, I can just delete the database. That's it. I don't have to run queries that might halt a database for while the data is being deleted. And D1 in particular has this feature called time travel that you can basically restore a database in a point in time. So suppose something bad happens on a user server, for example, and maybe they have, I don't know, maybe they are under attack, whatever, and they generate a ton of data that needs to be cleaned up. I can, for example, restore um, all data before something happened. This is an advantage of having individual databases. And I want to talk also about the fact that I can choose a region. When I create the database, I can choose where it should be put. And so this is in contrast with workers, which are deployed automatically across all over the world. For that D1 databases, we have to choose a region, and they are only in that region. So there is no concept of multiple D1 databases talking to each other. But we can have read replicas across all regions, which this might be something worth investigating, especially for big customers. But otherwise, you have to pick your region, and you will do that per your user account. So basically, you're gonna choose the one database that is nearest to your region, and I will automatically pick that for you. But you can choose a different region if you are, for example, building a website for people who live in another continent, for example. Yeah, this is the D1 database. And this is where we will store everything, all the data for a user account, a user workspace. Then we have key value store. KeyV is the name of the product on Cloudflare. This will be central to our architecture because this works a little bit like workers because it's automatically distributed across all over the world, and instances where when we write a new value for a key, it's automatically distributed across all the other instances of the KeyV store. So the way I'm gonna use this for our app is this. Basically, when you want to, for example, install a contact form on your site, you have the widget here, and you copy this snippet into your site. What happens is that anytime your web page is loaded after you embed this widget, it's gonna hit my server here, and it's gonna embed this particular widget. And what happens is that the worker is gonna basically go and fetch from the KeyV store the HTML for this widget. The database is untouched, so everything happens at the edge. So everything happens where you are. So for example, I'm in Italy, and I'm gonna load this from Italy. I'm gonna hit the Cloudflare servers in Milan, for example, which is very fast compared to loading this script from San Francisco, which is at the other end of the world, you know. So this is fantastic. And anytime, for example, you change this, if you change this, the configuration for this snippet, this widget, because you will be able to do so, or maybe, yeah, basically that is updated on the KeyV store. It's all automatic. That's fantastic. And another thing we are gonna use KeyV is to identify the customer's database. So basically, if you see here the widget, basically we identify each widget using an ID, a unique ID in the loading script here, and the worker is gonna identify immediately the database based on a KeyV value. So we don't have to go and ask our central database, um, who knows nothing actually about widgets. So I didn't say this, but we are going to have a central database, of course, for user accounts and whatnot. But then each specific user will have its own database, and the way, like the way we're going to identify the database given a widget ID is going to be through a key value store, which is going to be super fast. Then let me see here. Okay, we have workers, D1, key v, and another thing that's gonna be central is durable objects. Durable objects. Those are going to be central in our architecture. Basically, what happens since workers are globally distributed and we have multiple versions running, um, what happens if we receive, for example, a request to do something on a worker and the same request to do something else on the same on the same worker, um, like on the same worker but in another location? We need to serialize all the operations, and this is done using durable objects. Um, this is also going to be crucial for rate limiting. And the final two things I I'm using already are queues and cron jobs. Those are like standard things that you can find in any uh, application of any complexity. And those there is nothing worth talking about them. Queues are made to queue operations which are expensive or long, and cron is used to for maintenance, for example, or to yeah, maintenance is the word that describes everything. So that's it. I hope you found some value in this video, and I'm gonna talk about all these topics and aspects all the time because that's the architecture of the app. And if you have any question, if you have any suggestion as well, because that's the first time I use this kind of architecture on a real world application, just write a comment. See you.